Today we're going to dive into the world of bioluminescence, which is a phenomenon that transcends the boundaries between our virtual gaming experience in NMS and the natural world that surrounds us. Bioluminescence, whether witnessed in the realm of video games or the reality of our oceans, unveils the luminous magic of living organisms. It's the gentle glow of fireflies in the evening and the iridescence of marine creatures like the illustrious comb jellyfish. So this is a comb jellyfish. I'll begin with just a precise presentation on the topic, and after we can delve into a discussion about its in-game applications and ponder its potential evolution within the game in the future. So I'm going to talk about the science behind biolum in the real world. At its core, bioluminescence falls under the category of what's called chemiluminescence. It's a fascinating process where a chemical reaction gives birth to light. What sets bioluminescence apart is that it occurs within the very essence of a living being. Specifically, bioluminescence is actually cold light, which means that less than 20% of the emitted light is associated with thermal radiation. The pivotal character in the display is called luciferin, which is a compound whose very name means light bearer in Latin. It kind of hints at its role. So luciferin is the alchemical key that's responsible for producing the radiant light. Just a tidbit that some organisms actually lack the ability to synthesize their own luciferin, so they acquire it through symbiotic relationships with other organisms or by incorporating it into their diet. It's impossible not to draw parallels to our own living ships within the NMS universe. These vessels, with their uncanny resemblance to marine life and squid, serve as a vivid reminder of the remarkable symbiotic relationships that flourish in the real world. For instance, consider the symbiosis between squid and bioluminescent bacteria that's housed in their living organs, which is a great illustration of mutual benefit. The second component in the reaction is called luciferase, which is an enzyme which acts as a catalyst. When luciferase interacts with oxidized luciferin, oxidized meaning like oxygen's been introduced into the reaction, it leads to the formation of oxyluciferin, which is a byproduct, but it ultimately results in bioluminescence. I have actually a picture of the reaction if you're interested in the chemistry of it. So exploring the locations of biolum in the real world. So in marine bioluminescence, in the aquatic realm, marine organisms are the primary torchbearers of bioluminescence as a whole. The majority of these creatures emit light in the blue-green spectrum. So interestingly, most marine animals actually lack the ability to perceive colors in the yellow, red, or violet ranges. You just need to look at jellyfish and squids, even down to the plankton shown, which I'll put a picture up in a sec, that can create like a carpet of glowing light on the ocean. A lot of you probably have seen pictures all over the internet of the ocean where it's kind of looks like it's just glowing blue. That's actually the plankton and the algae that's within the ocean, bioluminescence in the plankton in the ocean. It's really cool. So land bioluminescence, so it's not just limited to the oceans. While marine organisms take center stage, land-based organisms actually have their moments as well. There's a species called Quantula striata, which is the only known land snail capable of bioluminescence. It resides in Southeast Asia tropics. The juveniles of the snail can actually produce faint flashes of green light, and the eggs actually glow in the dark, which turns the snail into a tiny terrestrial light show. If you're interested, that's what that little snail looks like. So fireflies are probably the most common land example. The most familiar example being lambfly. These insects emit their soft, intermittent glow to communicate and attract mates mostly. Notably, not all fireflies exhibit the luminous behavior, but a significant number of them do. It's believed that fireflies control their signaling by regulating the release of oxygen to the light-producing segments of their bodies. In North America, it's the male fireflies that actually light up the night sky in search of a potential partner. With approximately 1,500 known species capable of bioluminescence on Earth, fireflies are a shining example of the phenomenon on land. Cute little firefly. Intriguingly, bioluminescence isn't limited to the animal kingdom. Many fungi also possess the unique ability, just like the mushrooms you see on our planets and paradise planets that we're looking for all the time. And some of them actually glow with such intensity, like in the real world, that their light can be harnessed for practical purposes, like aiding reading in dimly lit conditions, because they can actually be that bright you can read by them. So what's like the purpose of biolume? Why do organisms possess the ability to create light? We don't have a complete answer for every species, but there are some widely accepted reasons behind it. It serves as a versatile tool in the natural world, primarily for communication and survival. In communication warning signal, so it's communication, but organisms display essential messages with their biolume. It serves as a warning signal to ward off potential predators, telling them, I'm not your prey or I might be toxic. It's a defense mechanism ultimately. It's also not limited to a single layer of the ocean either. It's prevalent across the entire water column from the ocean floor to the surface. So if you think about the immense scope of the ocean and the abundance of biolume life, it's actually, it's pretty vast. So it's believed that bioluminescence is actually the world's most common form of communication because of how many species there are that have it, and just how significant. Many organisms actually hone their skill in deception and trickery with biolume, so they use it to attract unsuspecting prey, leads them into deadly trap, and obviously, as I said, to avoid predation. So while we might not comprehend every facet of it, we appreciate the diverse ways in which organisms utilize biolume to thrive in their respective environments. In terms of the applications, this is where it gets super interesting for me. In recent years, scientists and engineers have harnessed the captivating power of biolume, unlocking its potential for various real-world applications. The practical uses are remarkable, are both diverse and promising. They offer innovative solutions across different scientific domains. One notable application is the utilization of something called GFP, or the green fluorescent protein. It's actually a reporter gene, which means that the GFP attaches to another gene that the scientists are trying to study. So the brilliance of GFP lies in the ability to serve as like a molecular beacon. It allows researchers to monitor and visualize the behavior of the gene it's linked to. GFP has been an invaluable tool in the field of like medicinal research. In cancer and cell culture studies, it means its capacity for real-time monitoring and imaging has really revolutionized the way scientists explore and understand cellular processes. Much of the research surrounding biolume falls under the category of what's called in science blue skies research. And what that means, it's like a free-form version of research. It's conducted without a goal or a hypothesis in mind. So like at school, we had to write a science experiment that had a hypothesis, you had a method, and then the conclusion at the end. Blue skies research just kind of removes all of those caveats and they just throw things at a wall and sees what sticks, They're delving into depths of biolume mysteries, see what emerges, and the open exploration, like the open-ended version of it, has led to amazing concepts, such as the experimental concept to make trees glow. Imagine using bioluminescent trees to illuminate areas, potentially reducing our reliance on electricity. Some innovative engineers have actually already embarked on projects aimed at creating low-emission lighting systems that use bioluminescent methods. Also in the world of agribusiness, as agricultural business, biolume holds additional possibilities. Imagine plants that can emit a soft glowing signal when they require watering. They offer like a visual cue to farmers and gardeners. The applications aren't confined to a lab, they have the potential to revolutionize how we interact with our environment. The implications of biolume in agriculture extends beyond mere convenience as well. It's potentially contributing to more efficient water usage and crop management. And, so the applications are nothing short of awe-inspiring, really. As we delve further into the potential uses of the radiant phenomenon, we uncover possibilities research to sustainable lighting and environment management. It shines a beacon of innovation and progress, guiding us towards a brighter and more sustainable future. So that's the end of my presentation part, and I just wanted to have a conversation with you guys about it, what your insights on it are, on bioluminescence as a whole in the game, what you think could be adapted further or further integrated, and just general ideas and thoughts on it. So thank you for listening.